We're back for the second part of the transaction verification episode from the Bitcoin Tech Tales series. In the first part, we learned how a node verifies the authenticity of a transaction. In this episode, we will focus on verifying the correctness of the transaction content. So grab your glasses, and let's go. Bitcoin transactions use coupons to reference the spending certificates for the payment. The coupons inform where to find the original certificates on the blockchain. Therefore, if the certificates specified on the coupons exist on the blockchain and Jane hasn't spent them yet, we will get their copy in this station. The blockchain courier takes the coupons and searches the blockchain for corresponding certificates. The node needs them to verify the funds at the following checkpoints. In our case, Jane didn't spend these certificates before, thus, the courier brought their copies. But if someone uses an already spent certificate for payment, the blockchain courier reports an error and aborts the transaction. In this way, the Bitcoin protocol prevents double spending of funds. The transaction, extended with the copy of the funding certificates, moves to the next station. At this checkpoint, the node verifies whether the owner of the certificates funding this transaction has provided proof of ownership. Let's mention again that for simplicity we assume that both certificates used for funding the transaction share the same Bitcoin address. Therefore, verifying Jane's ownership requires only one signature and one public key. Let's also recall that we used the private key to generate the public key and the Bitcoin address, as well as to create signatures. And that, at this point, the transaction has successfully undergone signature verification. Therefore, the node verifies if the transaction's creator owns funding certificates at this checkpoint. In simpler terms, it checks if the provided public key generates the same Bitcoin address as the one on the funding certificates. Together with a valid signature, they prove the ownership of the funds. ADDI calculates the Bitcoin address from the supplied public key, and the checker compares this address with all addresses from the certificates for funds. If these addresses match, this, together with the valid signature, proves the ownership of the funds as the certificates require it. On the other hand, if a villain wants to use someone else's certificates to fund the payment, the certificate's address differs from the address calculated from the provided public key, and the checker deletes the transaction. By reaching this station, the transaction has proven authentic and confirmed its legitimacy of ownership. Finally, we will examine the content of the transaction. Here we check if the funds are sufficient for payment and the fee. In addition, we also calculate the height of the transaction fee. The sum that the certificate owner wants to spend, placed here on the left side, is higher than the sum of the receiver certificates on the right side, as it should be. The difference between these amounts is the transaction fee. As in our example, the transaction fee must be higher than 1 Satoshi per virtual byte. However, if a transaction does not fulfill these rules, the node deletes it. We display the transaction's fee amount with a colored badge. After the node has checked the transaction, it no longer needs copies of the certificates retrieved from the blockchain. Next, it duplicates the verified transaction and forwards it to the neighbor Bitcoin nodes. The fee size is an essential attribute of the transaction for the miner node. For this reason, it marks the transaction with the fee value and sends it to mempool, which stores the transactions based on their fee height. The mempool is a waiting area where transactions wait to be included in a block. When miners generate a new block, they collect the associated transaction fee. The miner aims to collect as many Satoshis as possible by including transactions with higher fees in the next block. This means that the higher the fee, the more likely the miner will include the transaction in the next block. We've covered the fundamental principles of how a Bitcoin node verifies transactions. Every transaction is checked by each node, ensuring that the block contains only valid transactions. We'll begin constructing the candidate block in the next episode of our Bitcoin Tech Tales series.
Make sure to tune in.
See you.